right, good morning. We are doing geometry lesson 6.3, and this is on side, 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 and side angle, side congruence, triangle congruence. And so, again, this says as it relates to triangles. And, you know, these two initials are the ones that you use. SSS is for side, 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 obviously. And SAS is side angle side. And these are basically shortcuts to proving congruence. So you'll be able to recognize and prove that triangles are congruent if their corresponding sides are congruent only, without worrying about the angles. And the other one, side angle side, you'll be able to recognize and prove that two triangles are congruent if a corresponding side angle and side for each triangle are congruent. And you'll find that the angle is always in the middle. So side angle side. This lesson supports IXL skills for geometry K1 and K2. Be sure to take notes on this. You will upload this to me by Saturday. Okay, so this coming Saturday. All right, so let's talk about what these types of congruence are. And so how much do you really need to know about two triangles to prove that they're congruent? That is really our question. Previously, we've learned that you needed to know that the three corresponding angles and the three corresponding sides were congruent to prove that the two triangles were congruent. So that's a total of 6 plus 6 or 12 things that you would have to prove congruent, right? But the good news is that there are some shortcuts. And so we're going to look at two of them today. The first one being side, side, side congruence. This is the postulate for it. And remember, postulates are basically theorems based on other theorems. So this is really a theorem based on another theorem, sort of an offshoot. That's what a postulate is, okay? I think we've mentioned this before. So what this particular postulate or theorem says is if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. And that states it simply, but it really should be three corresponding. So if three corresponding, I'll put corresponding here, sides of one triangle are congruent to three, and then again it's corresponding sides of a second triangle, then the two triangles are congruent. So here you have two triangles. And so they tell you side MN, this is MN, is congruent to QR. Now, you know, the picture always tells you what it is you need. It always does. Always start with this picture, figure out what's happening in it. So you can see that those two sides are congruent. Why? Because the two tick marks tell you that. Then side NP, here's NP, is congruent to side RS. Notice there's two tick marks in each of these. That shows that they're congruent. What you need is a diagram like this with these signposts to congruency whenever you're looking at this. And then side PM is congruent to SQ. So here's PM, here's SQ. They have three ticks each. So that proves that the triangle MNP is congruent to QRS. Okay? Pretty simple. So a nice little shortcut to here. Now here's the other one we're going to look at. Now there are more shortcuts, but and we'll be going to those later, but this one is called side angle congruence. So this uses two sides and the angle that is included between the sides. So that's where the angle comes from. So side angle side. Here's the postulate or theorem. If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So again, if the two corresponding I don't want you to forget that these are corresponding sides, and the included triangle of one triangle are congruent to the two corresponding sides of the sides in the included angle of a second triangle, and it would be the corresponding included angle, right? Then the two triangles are congruent. So here you see it. Side PQ here is congruent to WX. Why? Because the little tick marks tell us so. Angle Q is congruent to angle X. Why? Because the arcs, the single arc on each one, shows us that it's congruent. And then side QS, here's QS, and is congruent to XY. Why? Because you've got two tick marks on each one. Again, the diagram or the picture always gives you proof. And you can develop your written out proof based upon the information that you see here. Okay? All right. So now we're going to do two short examples. And so example one, we want to prove that triangle PQW is congruent to triangle TSW. So PQW, TSW. These are two triangles that are joined at point W. And we're going to use a paragraph proof, okay? So, again, look to the picture for proof. Got to do that. So you draw this stuff out. You make sure you make note of this, and you draw all the information off of the picture into your proof. So you'll notice that PQ here has one tick mark, line segment PQ. So does TS. So those two line segments are congruent. PW here is congruent to W. I guess it's WP is congruent to WT. Why? Because of two tick marks, okay, on each of those two line segments. And WQ here is congruent to WS. Why? Because of the three tick marks you see in each of those. So you've got corresponding sides, three sides, all right? So basically what we would say in a paragraph proof is, you know, what's happening and what the reason for it is in a paragraph. This is going to be more bulleted, but let's do it this way. So here's my proof. The marks on the diagram to the left, I'm just going to say the diagram, show that PQ is congruent, so this is line segment PQ, is congruent to line segment TS. PQ, TS. And then PW is congruent to TW. Okay, they showed them in the reverse of the way I expected to when they described them, but that's all right. PW is congruent to TW. Okay, and let's see, what's the third one? QW is congruent to SW. Now that's the way I would have expected it described. So QW is congruent to SW. There you go. All right, so that's what it's showing. All we did was look to the picture and we wrote down what we saw here. That's it. That tells us basically the statement. You know, it's kind of the statement in a two-column proof. Now the reason So the reason, we're going to just simply say therefore, because there's really only one step to this. By, what do we say this side congruence, right? By the side congruence postulate, you know that triangle PQW is congruent to triangle TSW. Okay? And that's it. Why? Because we said side, right? We said that, you know, if you look to this, obviously this is side congruence. And you know from the theorem or postulate that we showed you just a moment ago, or I should say minutes ago, that whenever you have the corresponding sides congruent, then the two triangles are congruent by the side congruence postulate. Okay, that's it for example 1. Pretty easy. Okay, now we're going to go to example 2. So example 2, oh, we got a blank proof. Oh, scary thing. Here we got to prove that triangle AEB is congruent to triangle DEC using a 2-column proof. So look to the picture, right? What does it show? Well, it shows that, let's see here, I think this is AE. AE is congruent to DE. Notice they have one tick mark. Okay, so that's a side. And they also show another side. In this case, it's BE is congruent to CE, right? 2 tick marks each. Now, they don't show you anything else, but what do they show you? They show you angle 1 and angle 2. Now, what do we know about angle 1 and angle 2? Notice they're in an intersection. And so if they're in an intersection, those got to be vertical angles, right? Vertical angles. That's what's happening right here. And we know that vertical angles are congruent. So we can put this, you know, one arc on each side and say that vertical angles are congruent. So once we acknowledge that, now we have side, angle, side, angle, side. So we've got side, angle, side congruency. So therefore, side, angle, side congruency. Now, I just wrote everything that I would write here in abbreviated form. And I did that also in the previous proof that we did that was just sort of a paragraph proof. You can just scratch notes on the side of your picture. You could get everything else, everything that you need. So let's start at what did we start with? We talked about what was given to us. We were given the sides. So we said that AE here, AE, line segment AE, is congruent to line segment DE. Right? And we also said that BE, line segment BE, is congruent to line segment EC. I'm sorry, CE. CE. Okay? And reason, well, that was already given to us. So our reason is given. Right? All right. So then the next thing we noted was angle 1 and angle 2 there. So let's write them down. Angle 1 is congruent to angle 2. We found that out because they were vertical angles. So that's got to be the reason. So that's the vertical angles theorem. And so now we have enough to prove the whole darn thing. We can say we've got side angle side because we've got those vertical angles. So side angle side, side angle side. So we can say, therefore, triangle AEB is congruent to triangle DEC. And the reason, of course, is the side angle side congruence theorem, or postulate, either way you want to show it. And I'm just going to put parentheses postulate, because that's technically what it is. Okay, so guys, why are these so short and simple and sweet? Because these are shortcuts. They're shortcuts. Very easy to do. So with these shortcuts, you can start moving faster through all of the work that you're doing when it comes to triangle congruence. And there will be more shortcuts. We're going to show you some more in the next video. So stay tuned. Stay tuned for lesson, what was this? It was 6.3, I think. Yeah. So stay tuned. For lesson 6.4. Which is going to cover more congruence shortcuts. Okay, so that's it. We're done with this one, ladies and gentlemen. I'm going to go ahead and finish the upload, and we'll be ready to go. Thank you very much. Bye-bye now.